Okay, I'm going to see if I can turn my health checks into a decorator. So it's a NestJS project, and I have a health check function for Zeebe workers using healthchecks.io. This is I've got it at the moment inline in each of my workers, and I want to extract this into like a decorator that I can put on the method. So I'm not sure how this will interact with Nest, but let's find out. Okay, so I'm going to create a health check decorator here. healthcheck.decorator.ts. Okay, so let's have a look at decorators. TypeScript decorator. Here we go. Decorators. Class decorators. Method decorators. Here we go. Okay. So this is what a method decorator looks like here. But I think there's a better example. Maybe here. Debounce, here we go. This is more kind of what we want to do. Oh. Okay. So what you do is you grab the original method from the descriptor value and then put your new method on and then return the descriptor. So let's get that signature again. Method decorator signature. Here it is. So we'll grab that, punch it in there, change it to with health check. And it takes a URL, which is a string. The first thing we do is grab the handler, like that. Go back here, and then, let's see. So now I'm going to replace the original method with the new one. Export this. Okay, the health check variable, it's the only thing. Okay, so I'll make it a constant. Rip it out. I could make another decorator that sets metadata on the class. I'll do that later. I'll just do this to see if it works. Okay, so there's the method decorator. This is a decorator factory. So it's going to take a URL and return a decorator. And then it's going to do that. I don't think we need to return anything. No, you just directly mutate it. Return descriptor in here. Return descriptor. Okay, well let's try it. Try it with return descriptor. Here. So we return the descriptor. Okay. So now if I go down and annotate this with go back here, make that a capital W. Call it Zeebe health check. So I should be able to do this, Zeebe health check, and then I put this in like that. Dolphins. And then I should be able to delete that, and that should compile. Let's see, npm run start dev. NestJS has got some good tooling that it sets up for you. This is a watching compiler. Cannot find health check variable. Okay. So here, put it on here. Drop it in there. Guess I could have checked it with one of them by keeping that variable in place. Let's do that. Make sure it compiles before I go mutating too much code. Zero errors. Okay, good. Oh, you're looking at that demo there. Let's go back to this. Zeebe endpoint. That's what you want to be looking at. Transition. Okay, so I wrote my decorator. I export a function. This is a decorator factory, so it takes a parameter, a URL, which is a string, and here's the method decorator here. It takes a target, a property key, and a property descriptor. And then I put the original handler, which is a descriptor value, it's the method, into this local variable handler, and then I replace the method with my own custom implementation, which does the health check. And if it's not a health check, it's going to call the original method. And here's what it looks like when I put it on the method. So right here, here's my original Zeebe worker method, it's the worker handler, and then I put my decorator on it. So I call the decorator factory, I get a health check for that URL, and then I wrap this method with it. And it looks like it went through. Okay, that seems to work. Okay, great. Winning. Okay, so I'll do it to all of them. So, should be easy for me to publish this as a package. Go here. Yeah, I've started going to sleep once I hit a certain point, because I know if I just sleep on it overnight, I'll come up with something. Also, I watched my video yesterday and I was like, dude, you forgot to close your parentheses. And when I was looking at that, I was like, I kind of had an expectation that Nest would be real complicated and do some kind of magical thing that would make my idea not work. So I was expecting it to not work. So I didn't look at it close enough to see that it was a syntax error. Okay, doesn't like that because of that. There we go. So now I can wrap my Zeebe workers with health checks. And then what it will do is if it gets a payload that has Zeebe healthcheck as a variable with some kind of truthy value, so I just set it to true. Any payload it sees with that variable in it, it's going to basically ignore the normal handler and call the health check. And the health check is bound. I mean, another way I could do it is I could pass in a map of health checks to task types and then have the worker look its health check URL up, which means I can take the no, it'd be hard to environmentalize it then. Unless I made environmental a map. So the map would look something like this. Const payload equals, and then it would go Zeebe health check like this. And then it would be environments, and then it would look like this. So you got your task type, and then the URL. So it would look like that. They could also work. So this could also be undefined, like if you didn't have it in there, it would miss it out. So that's an option too. Trailing comma? Yeah. New line. So we could do that. In which case, if I did that, we would punch that in here. Anyway, I'll go with this for the time being. Started the health check process. So to test if it works, we can do this. So I go to Chrome, go to my health checks page on healthchecks.io, and you can see 31 seconds ago. 34 seconds ago. So nothing is scheduled for the next 8 minutes. But if I go here and save that, it's going to reboot the app. It's restarting. Yep, I called them. Okay. Turn that off, go back here. Okay, so it works. I can write a health check decorator, and then I can decorate it. So, you know, if I move this out, yeah, it's going to be easier to environmentalize. Because I'm going to have to put in a map somewhere. I might as well put it into the BPMN, which means that I could, rather than redeploying the application, I would just kill the existing process and start a new one with new variables in it to change it, so it gets rid of this hard coupling here. Okay, I'm going to do it. Okay, is health check is that? If it is a health check, so, well, in here let's go const end equals process dot end dot process end prod. Node end. Here we go. Export node end equals. Okay. That's the convention. So, okay. So here we would call this the health checks map. In that case, I should probably inject a map. So I'll take this map out of here, put it into here. This controller's getting pretty big, but whatever. So I can get rid of that. Now, could put that at the top level, so it would go like this. So change this to production, make that development. And then we've got to put a map of the task types in there. So let's do that. Okay. Now, because it has dashes in it, we've got to quote it. There we go. Programming with no tests. I say that because my brain is now going, I'm holding a lot of state of the application in my head. So ideally I'd write test, but I'm just doing this fast and dirty right now. Which means that when I come back in the future and try to, I'm going to have to recreate all of this understanding in my head. Clean up user. Retrieve spells. So in production, retrieve spells. So in production, I'm going to need to set that variable in the environment. Control C, Control V. Retrieve spells. We did that one. We can rip that out. Oh, this makes it so much simpler in terms of the code, because I'm drying the functionality out into a decorator, so I can just annotate the method with it. It's called aspect-oriented programming. You dry out the kind of horizontal concerns. That one's show connection message. Put them in one place, test them once, implement them once, and then the surface area of the connection between the method and this, functionality is very small. Send message. And that's the idea behind NestJS, is applying that kind of architectural paradigm to your code. So take this, send message, and that should be a colon. I don't use semicolons, so I remapped my semicolon key to the colon so I don't have to press Shift key. Deassociate the user. It's for testing, really, that one. So I can test the user flow by continually deassociating myself and then reassociating. Okay, pop that one in there. 1, 2, 3, 4, 5, 6. Okay, I know that we have 6, so we're done. Now rip out all of this stuff. Goodbye. And then I can get rid of the URL, and then what I should do instead is inject the map. So health checks map, see? V. Problem though is, does this thing know what its task type is? It doesn't. See, when we're in here, we don't know what the task type is. Okay, I do know a way around that. If I go here, transition, NestJS, set metadata. I can set metadata on my class. Guards, make set metadata work with controllers. Set metadata works with methods. Metadata on the entire controller. Works with controller. Set metadata works on the controller methods. Okay, you got to get the reflector in it. Injectable. Let's try it out. I don't know if this is going to work, but let's see. Set metadata director. Service instance inside a decorator. Let's try this one. Guards. Authorization guard. Execution context. Binding guards. Here we go. It's down here somewhere. Reflection. Set metadata. Import set metadata. Roles. Okay, NestJS common. So I'm going to set the metadata on there. Task type. I've already set the metadata here though. Let's see what this does. Method decorator. Okay, so it's already got a method decorator on it. Where is that? If I go down here, NestJS. Here we go. Nope. Zeebe NestJS? No. Reveal in sidebar. Here we go. Node modules at payk. That's right. Nope. At payk. Zeebe decorator. Zeebe.decorator. Yeah. It takes the type and passes it into there. It doesn't set the metadata. Okay, well, we'll dry it out later. Okay. So, in my health check decorator, create another one. Task type, yes, equals, and then the task type goes here. It's a string, set metadata, task type. And export that. Okay, so go back here. Zeebe health check and task type. Like that. And then I should be able to do this. I would, because you're having to repeat yourself here, I'd merge it up into that Zeebe worker. Pull request it in, if I can get it working. Okay, so here's the Zeebe health check. Now we need to be able to get that. Let's see. reflector. I don't know if this is going to work. Reason being that to get that metadata back out, I need to import this reflector from NestJS core, but then it looks like you can only use it in a class where you inject it. I wonder if we could make the decorator factory a class, injectable, put the reflector in the constructor, and then use it here. Could be. Let's see. Let's try it. So turn off the Chrome, transition back to here. Okay, so in that case, how we would do that is we'll go back to the decorator, not that one, not that one, health check decorator. So we would do make it injectable, export class, so just call it Zeebe health check. Maybe Zeebe worker, Zeebe health, I don't know, whatever. Zeebe health, and like that. And then in that case, we grab this whole thing here, Control X that, Control V it, and then change this to Zeebe health check, take off the URL, and then make the constructor okay, we'll just map this class would get constructed for every will get constructed once. Okay, so target, we should be able to get the metadata off the target. That's the name of the method. Yeah. So my roll guard. Grab that constructor signature. Ta-da. This reflector comes from NestJS core. Injectable. Yep. Set the metadata. Now, I don't know if this is going to work, but let's see. This reflector gets string. Set it as task type. And we're going to get it from the target. Task type. Save. Yeah. So I guess I put the map in here. Let's make make it any for now. Comma. If is health check. And so constructor. I'm not sure if it automatically assigns those properties, so I'll do it here. Map. So we need to get the environment. Env. Oh, optional property chaining, please. Task type. So dumb. V. I guess since it's in a try block, I could just do it anyway, and with exception, who cares? No exported member Zeebe health check. Okay, it's called Zeebe health, and has a check method. Can you do this? Yeah. Get rid of that. I don't know if you can do this. Property check does not exist on type of Zeebe health. At Zeebe health. So maybe it needs to be a static method? No, because then I got nothing from the constructor. It's not callable. Okay, maybe. Let's go back to the TypeScript docs. Control F metadata. Maybe I write my own metadata reflector. That, and then just reflect get metadata. Property decorator, method decorator, configurable properties. We can record metadata about the property. Metadata entry. TypeScript compiler will inject design time information using the reflect metadata decorator equivalent of the following JavaScript. Following TypeScript at reflect.metadata. Decorator metadata, yeah, whatever. Okay, so decorator metadata for method. Method decorator. Decorators, metadata reflection. Parameter decorators. Experimental decorators, reflective. Access class metadata from a method decorator. Class decorator, method decorator. Class decorator defines metadata. Okay, in order, the method decorators are executed first, class decorators later. Method decorator, reflect define metadata. Okay, looks like it'll work. Let's try it. Metadata. Okay, import this. So we're going to get rid of that. One. We have to convert this back. Export function. Zeebe health check. It's a function. So that. Let's use a const then. Happy? Get rid of the injectable. Okay, so let's reflect it. How do we get this? Okay. Task type. And we want to get it off the reflect get metadata. Parameter. A key. Target, the target object. The property key. I found no. I need another example. Get own metadata. Okay, let's see what else is in that reflect package then. So reflect dot decorate, define metadata, get metadata, get own metadata, has metadata, metadata. So get metadata. Target object. Well, the target object is a function. What's the property key? Actually, no, it's a class method. This is decorators, so we want to do metadata, TypeScript. So let's try this one. Decorate the class, decorate the properties. Type. Method decorators. Yay! Method decorator. Target. Property key. Descriptor. Method decorator. Yes. Okay, that's the method decorator. Metadata reflection API. Properties. Type serialization, complex type serialization. Can you only do property metadata? Return type metadata? Design return type, that's pretty cool. Okay. Method of a class to get the types of its in design time. Params, target key. Okay. So I think, you're not even seeing this. Gosh. Chrome, this is what I'm looking at. This is from decorators and metadata reflection and TypeScript from novice to expert. Complex type. The interesting thing for me here is this one. Complex types, basic types. Here, obtaining the return type metadata of a method. So I'm interested in methods. And you can get, it looks like this. Reflect get metadata, what it is that you want to get. So that'll be task type. And then you just say target and key. I don't think you saw that either. It's from here. Decorators and metadata reflection and TypeScript from novice to expert. Part 4. And down here, complex type serialization, maybe before that. Here, obtaining the return type metadata using the reflect metadata API. So you can get it like this, reflect get metadata, the key, which will be task type, and then target and key, which is just coming in from there. So, according to my ghetto calculations, if in our decorator we have coming in target and key, target, key. Okay, that should actually work. How about you just fix that? Thank you. Injecting the map. I could put the map in here, however, whatever. Ta-da! Fixed it. Here goes, easy injection. So it's called Zeebe health check. Okay. So now you go like this. Equals Zeebe health check, and then just inject the map there. Ta-da! Ghetto injection. So then my annotation becomes like that. Expected 3 arguments. Let's have a look. Map. Before it would take the URL. So in that case, I just need to do this. You know what, I could put the task type there. That'll make it easy. Yeah, so put the task type. Get rid of that metadata reflection altogether. Like that. Save. Winning. So now we do this. Like that. Nice. Okay, so we got an environmentalized decorator. And we can delete code. Yay! Less lines of code is good. And then we remove the Axios dependency from here. This health check variable. So what we could do here is kind of what happens with subscription correlation is I could put variable name and whack it in there, but whatever. Just leave it like that. It's fine. We don't need this anymore. We don't need this. We don't need this. This can come out of here. And then what I might do, just for my own sanity, I don't need that. We're not using that. Yeah. Oh. This doesn't look good. It's calling this. I see. Right. We need to do this. You know what? Screw it. Let's just do that. Boom. this into catch. Okay, so what this does is, because process env, node env is undefined right now, it's hitting this part here and then throwing an exception because the map has no undefined task type. If I wanted to test it, I could do a local host for development. Okay, well, I think that's working. Let me just try this. Node env equals production. Like that. Started. If we go to health checks, 7 seconds ago. Yeah, so it's working. So you have a health checks map defined for the environment. So then I need to set my production environment in the Docker container. Production Docker compose. Yeah. Anti-pattern. Got my Kumunda Cloud secrets in there. So have a look at this wonderful picture of operating Kumunda Cloud while I just go in there and modify that. Docker production, Docker compose, environment, node env equals production. And we're back. So, let's try running it. So connect my thing. Go here. Okay. Oh yeah, I guess I should push these changes. So the changes are quite minimal. I wrote a decorator. And there's not much code to that. It's like, what, total of 27 lines, and they're not all completely full. And then in the controller, I added the map, created a health check from the factory, and deleted all this imperative code from each of the workers, the stuff here on the left, and replaced it with a nice decorator. So it's good. Total amount of code has been reduced. So I'm going to git push that. So make health check a decorator. And I got a TypeScript compiler problem. So I have to git with one of the components in this project, one that runs in Minecraft. It's m no verify. I should alias that. Git push. over here. I'm going to pull it down to this machine. Okay. Boom. Okay, something looks like it's wrong. And here's what it is. If you have a look at this, the bottom 5 workers all checked 16 seconds ago. This top one, 6 seconds ago. They should have all checked at the same time? Polling, broker? Dude, I don't know. Let me make sure that that first one is actually set up properly. Let's retrieve Magic Craft account. Yep, it's there. Okay. Make sure the decorator is correct. Retrieve Magic Craft account. Looks good. Okay, final test. Let me actually connect to the Minecraft server. Add a window capture so you can see what's happening. Minecraft. Create a new one. And should be this one. Okay. Transition. Okay. Go. Oh. Shout out to Mo Yang. Go. The moment of truth. Boo. Cancel. Quick game. Let's try it again. Wow, I gotta log back in again. Okay. Keep me logged in. Invalid email or password. Let's try a different one. Wah. Oh. Maybe it doesn't like my VPN. Could be. Try disconnecting from my VPN. Okay, I'll have to sort out my Minecraft login woes later to test it. Anyway, at the moment, as far as I can tell, it looks like it's working. The health checks are working at least, but I got to see whether the actual underlying handler works. I'm quite happy with that code though. It's dried out a lot since yesterday. Programming is about data and algorithms, and separating the two of them is important. So I've got now all of my data in one place, workflow controller, and my algorithm in another place. And when you mix the two together, that's when you have problems with refactoring, reasoning about the code, and it's also leads to more bugs. There's more places where things can go wrong. Okay, that's enough for today. Later on I'll get my Minecraft working and then demo it actually working.